Next question. The ratio of the arithmetic mean and geometric mean of two positive numbers a and b is m is to n. Show that ratio of a and b is equal to, represented by this ratio. So say here, let a and g be arithmetic mean and geometric mean of two numbers, two positive numbers a and b. So a is equal to a plus b by 2 and g is root ab. Now given that ratio of am and gm is m is to n, so here given that ratio of a and g is m is to n, so m by n, that is given. That means a plus b by 2 upon root ab is m upon n. That means now simplifying this, we can get ratio of numbers a and b. So say 2 I am taking in denominator, a plus b upon 2 root ab is m upon n. Now we apply componendo dividendo rule. So numerator plus denominator upon numerator minus denominator. Same on right hand side, numerator plus denominator upon numerator minus denominator. So this is now root a plus root b whole square. Denominator is root a minus root b whole square. It is equal to m plus n upon m minus n. So root a plus root b, therefore root a plus root b upon root a minus root b, it is equal to, now see, first number, if it is greater and smaller number is, first number is greater and second number is smaller, then this difference will be positive. So in the beginning here we suppose that a is more than b. In the beginning we are supposing that a is more than b. So here because a is more than b, so root a plus root b upon root a minus root b, we take positive square root. So square root of m plus n upon m minus n. Otherwise we should keep here plus or minus, but we are taking positive square root because root a is more than root b, because a is more than b. So this condition is taken. We have suppose a is greater, b is smaller, so this will be positive. Now see once again, now see this radical sign is over m plus n, m minus n. So observe this as individual sign, root m plus n upon root m minus n. We want ratio of A and B. So once again, using component or dividend rule, numerator plus denominator, numerator plus denominator upon numerator minus denominator. Same procedure on right hand side. Numerator plus denominator upon numerator minus denominator. So this is then, see root b is cancelled. So 2 root a upon, here root b 2 root b, root a will be cancelled. So it is 2 root b equal to root m plus n plus root m minus n upon root m plus n minus root m minus n. This 2 is cancelled. Now once again squaring on both the sides, squaring on both the sides, because we don't want here radical sign. So square of right hand side. Squaring on right hand side. So therefore root a upon root b whole square, that means a upon b equal to, now expanding this, x plus y whole square. So x square plus y square plus 2 root ab, root a into b, that is m square minus n square. Similarly here x square plus y square plus 2 root x into y, so m square minus n square. So here n is cancelled, here m is cancelled, n is cancelled, here also n is cancelled. So that is a by b is m plus m, 2m plus 2 root m square minus n square upon 2m plus 2 root m square minus n square. So now 2 is common, so cancel 2. So a by b is m plus root m square minus n square upon m plus root m square minus n square. So required ratio is a is to b is m plus root m square minus n square is to m plus root, say here I think I did mistake, this is m minus n, m minus n, m plus n, m minus n, this sign is minus, middle term is negative, so here we have to put minus. So here this will be minus. So m plus root m square minus n square, m minus root m square minus n square. So this is required ratio. Now next question, find the sum up to n terms of this series. Say look here, this is neither AP nor GP. If you multiply 0.6 by 11, then you get 0.66. But 0.66 into 11 is not 0.666. So it is not GP. It is also not AP. So in such type of series, what we do? First of all, we take From these all numbers I am taking 6 common. Here required sum is 0.6, 0.66, 0.666 up to n terms. Now procedure is I am taking 6 common. Taking 6 common inside 0.1, 0.11, 0.111 up to n terms. This is the procedure. 6 is taken common. Then now divide this by 9. Dividing by 9, this is fixed. Always divide by 9. So inside the series will be series of 9s, 0.9, 0.99, 0.999 up to n terms. Then next step, 6 by 9, 0.9 is 1 minus 0.1. 0.99 is 1 minus 0.01. 0.999 is 1 minus 0.001. So we have such n brackets. This is the method. And now we are getting GP. From these brackets we can separate a GP. Say here 6 by 9. From every bracket I am collecting 1. 1 plus second one plus third one, that is n times 1. From every bracket in second place numbers I am taking by taking minus, putting minus common. So 0.1 plus 0.01 plus 0.001 plus up to, there are n brackets, so n terms. So 6 by 9 into bracket, sum of these numbers 1 plus 1 plus 1 n times is n minus. Now see, this is GP. It is GP, geometric progression. Series associated with geometric progression in which first term is 0.1. First term is 0.1, ratio is also 0.1. So putting these values in this formula, a into r raised to n minus 1 upon r minus 1. Here we are getting value for this expression. A is 0.1 into 0.1 raised to n minus 1 upon 0.1 minus 1. A into r raised to n minus 1 upon r minus 1. So this is equal to 6 by 9 into n minus 0.1 upon, this will be minus 0.9, minus 0.9. So minus minus plus 0.9 into bracket. This will be 1 by 10 raised to n minus 1. 0.1, that is 1 by 10 raised to n minus 1. So this is 6 by 9 into n plus, this will be 1 by 9 into bracket 1 by 10 raised to n minus 1. So multiplying this number 6 by 9 into n, so 6n by 9 plus 6 by 81 into 1 upon 10 raised to n minus 1. This is required value. Say here we want sum of first n terms of this series. Look here, 3 plus 4 is 7, but 7 plus 4 is not 13. Here there is no common difference, so it is not AP. If you check about GP, then here you cannot find common ratio. So this series is neither AP nor GP. So how to find sum of such series? The procedure is, here we want sum of n terms. Sum of n terms is 3 plus 7 plus 13 plus 21 plus 31 up to, suppose its nth term is an. This is nth term. And now this line, once again I am repeating this line. Repeating once again I am repeating, but repeating with trick. What we do, Sn equal to, keep first place blank, first term 3 keep below 7, 3 plus 7 put here, 7 plus 13 put here, 13 plus put here 21, put here 31. Continuing this procedure, so this will be, an will be here in the next place, and before an here this will be an minus 1, second term from last, n minus 1th term will be there. So first line is repeated but differently. Now what we are doing, we are taking subtraction of 1 and 2. From 1 and 2, Sn minus Sn, taking subtraction, subtracting from 1, subtracting equation number 2 from equation number 1. So see, Sn minus Sn is 0. 3 minus, here consider this 0, put here 0, first place keep 0. So 3 minus 0 is 3. 7 minus 3 is 4. 13 minus 7 is 8. 21 minus 13. That is 13 minus 7, sorry, it is 4. 7 minus 3 is 4, 13 minus 7 is, 6, it is 6. 21 minus 13, it is 8. 31 minus 21, this is 10. Continuing this procedure, here at last term will be, here you consider 0. So 0 minus an is minus an. 0 minus an is minus an. So say here these are, including 0, these are n plus 1 terms. Including 0, these are n plus 1 terms. So this is n plus 1th term. This is n plus 1th term. So these are n terms. Number of terms are till this term. These are n terms. So next step is, now minus an I am taking on this side. So plus an equal to 3, first term keep as it is, plus, now 4 onwards keep in bracket, now check, In bracket, these are how many terms? These were n terms, but 3 is separated. So how many are left? So these are n minus 1 terms. N minus 1 terms. Separating 3, remaining are n minus 1 terms. And here you can see that this is AP. This is arithmetic progression. Series associated with AP. Here first term is 4. Common difference is 2. And we want sum of n minus 1 terms. Sum of n minus 1 terms. So this is equal to 3 plus, now sum of n minus 1 terms, we are using this formula. Sn is n by 2 into 2a plus n minus 1 into d. So n will be replaced by n minus 1. We are replacing this n by n minus 1. Here I am going to put n minus 1. So sum of n minus 1 terms is n minus 1 by 2 into 2a. What is a? A is 4 plus n minus 1 minus 1. Difference is 2. Close the bracket. So this is 3 plus n minus 1 by 2, 8 plus this is n minus 2 into 2. So 2n minus 4. So that is 3 plus n minus 1 by 2 into 2n plus 4. Now here 2 can be cancelled. So an is, therefore an is 3 plus n minus 1 into n plus 2. 2 is cancelled. That is, it is equal to 3 plus n square plus n minus 2. So this is n square plus n plus 1. So therefore an is n square plus n plus 1. This is nth term. We are not asked to find nth term. We are asked to find sum of first n terms. So now we are coming on required sum. So required sum is, it is equal to sigma a, that means a1 plus a2 up to an, sum of n terms. That is required sum. So that is sigma a k. K is 1 to n. N is replaced by k. K is now variable for sigma. Now a k. So a k is, say a k, you can replace n by k. So a k is k square plus k plus 1. So k square plus k plus 1. So this is equal to sigma k square, k 1 to n plus sigma k, k 1 to n plus sigma 1, k 1 to n. So this is equal to sigma k square is n by 6 n plus 1 to n plus 1 plus sigma k is n by 2 n plus 1, and this is n. Now you can see that here n is common. I am taking n common. So what is left? Here 2n square plus n plus 2n, that is 3n plus 1 by 6 is left, plus here n plus 1 by 2 is left. plus 1. So again here 6 is LCM. So continuing here, this is equal to n into, here I have space, n into 6 is LCM. So 2n square plus 3n plus 1, 3n, now multiplying this by 3, 3n plus 3, 3n plus 3, 3n plus 3 plus 6, plus 6. So it is equal to n by 6 into 2n square, 3n plus 3n is 6n, 6 plus 3 9, 9 plus 1 is 10. Now divisible by 2, so n by 3, n square plus 3n plus 5. So this is required sum. It is required sum. So after this step you go from this step. Find the sum of following series up to n terms. We want sum up to n terms. This is first term, this is second term, this is third term. So by observation we put nth term. So in given series, nth term is, first term it is 1 cube, second term numerator is 1 cube plus 2 cube, in third term numerator is 1 cube plus 2 cube plus 3 cube. So similarly in nth term numerator will be 1 cube plus 2 cube plus 3 cube plus up to n cube. And denominator, first denominator is 1, second denominator there are 2 odd numbers, third denominator first 3 odd numbers, fourth denominator first 4 odd numbers. So nth term, nth denominator first n odd numbers. So 1 plus 3 plus 5 up to n terms, up to n terms. Here we can put nth term. It's easy because these are natural odd numbers, and nth term, expression for nth term for natural odd number is 2n minus 1. If we can keep this is as nth term 2n minus 1, because for n equal to 1 this is 1, for n equal to 2 this is 3, for n equal to 3 we get 5. So continuing this is nth term. Now this is equal to, now this can be expressed as sigma k cube, k equal to 1 to n. Denominator can be expressed as sigma to k minus 1, k equal to 1 to n. So that is equal to, now sigma k cube k 1 to n, that is n square by 4 n plus 1 whole square. Here 2 distribution of sigma, so 2 times sigma k, k is 1 to n minus sigma 1, k is 1 to n. So it is equal to n square by 4 n plus 1 whole square upon 2 into, now sigma k is n by 2 n plus 1 minus sigma 1 is n. This is cancelled. So n square by 4 n plus 1 whole square. Denominator is n square plus n minus n. This will be cancelled. this n square will be cancelled, so it is 1 by 4 n plus 1 whole square, that is 1 by 4 n square plus 2n plus 1. It is nth term of this series. Therefore n is 1 by 4 n square plus 2n plus 1. So required sum is, therefore Sn is a1 plus a2 plus up to an. We want sum of n terms, that is we want sigma ak k equal to 1 to n. Here I keep n, replace n by k, so ak k 1 to n, that is sigma k equal to 1 to n. Now from this equation ak is 1 by 4 times k square plus 2k plus 1. Now distribution of sigma, so 1 by 4 times sigma k square k 1 to n plus 2 times sigma k 1 to n plus sigma 1 k 1 to n. Now putting values, 1 by 4, this is n by 6, n plus 1, 2n plus 1 plus 2 into sigma k is n by 2, n plus 1 plus n. Now here this 2 is cancelled, n is common, taking this n common, so n by 4, expanding this 2n square plus 3n plus 1 upon 6 plus, here n is taken outside, so n plus 1 is left, here 1 is left. Now LCM is 6, so here divide by 6. Now inside 2n square plus 3n plus 1 plus multiplying this by 6, so 6n plus 6 again plus 6. So this is equal to n by 24 into bracket 2n square plus 3n plus 6n is 9n. 6 plus 6 12, 12 plus 1 13. So this is required sum. Show that this is equal to 3n plus 5 upon 3n plus 1. We are beginning from left hand side. Left hand side is 1 into 2 square plus 2 into 3 square plus up to n into n plus 1 whole square upon 1 square into 2, 2 square into 3 up to n square into n plus 1. Numerator represents a series, denominator represents another series. Now here say this value, this can be represented in compact form. This is first term, this is second term, this is nth term. So this sum can be represented as sigma. This is nth term of numerator, replace n by k, so k into k plus 1 whole square, k equal to 1 to n. And similarly this denominator can be represented in compact form as nth term, replace n by k, so k square into k plus 1, and k we are using as a variable 1 to n. So this is equal to sigma k equal to 1 to n. Now its expansion is k cube plus 2k square plus k. upon here expansion is because sigma is not distributive over multiplication, so k cube plus k square. Now distribution of sigma sigma k cube k1 to n 2 times sigma k square k1 to n plus sigma k1 to n divided by sigma k cube k1 to n plus sigma k square k is 1 to n. Now putting values, sigma k cube is n square by 4 n plus 1 whole square plus 2 into sigma k square is n by 6 n plus 1 2n plus 1 plus sigma k is k by 2 n by 2 n plus 1 upon sigma k cube k1 to n, it is n square by 4 n plus 1 whole square plus sigma k square n by 6 n plus 1 2n plus 1. Now look, from numerator, say this part will be common, n by 2 n plus 1, here n plus 1, n into n plus 1 we are taking common, this is 2 into 3 6. So n into n plus 1 common, here n into n plus 1 common in numerator. So what is left in numerator? So here n into n plus 1 is left, divided by 4 is left, plus n into n plus 1 is taken out, so 2n plus 1 divided by 3. Here 1 by 2 is left upon similarly in denominator n into n plus 1 is common, so here n into n plus 1 by 4 is left plus 2n plus 1 by 6 is left, so this is cancelled. Now here we are taking LCM of 4 3 and 2, LCM is 12, so in numerator LCM is 12, so this will be multiplied by 3, so 3n into n, 3n square plus 3n into 1 3n, this will be multiplied by 4, so 8n plus 4, this will be by 6, so plus 6. In denominator LCM of 6 and 4, it is also 12, this will be multiplied by 3, so 3n square plus 3n, this is by 2, so 4n plus 2, so this is cancelled. So 3n square plus 11n plus 10 upon 3n square plus 7n plus 2, this is required sum. Say here Shamshad Ali buys a scooter for rupees 20,000. He pays rupees 4,000 cash and agrees to pay the balance amount in annual installment of rupees 1,000 plus 10% interest on the unpaid amount. How much will the scooter cost him? So here in this question, cost of scooter, price of scooter is rupees 22,000. Now he pays 4,000 cash, so paid cash amount 4,000 rupees, so this will be minus, so outstanding balance will be 18,000. This is outstanding balance. Now this 18,000 outstanding balance he is paying in installments. The method is he agrees to pay the balance in annual installment of rupees 1000 plus 10% interest. So this 18,000 amount he will pay in 18 installments, and at the end of every month, annual installments, here these are annual installments. So 18,000 amount he will pay in installments of rupees 1000 plus 10% interest. So 18,000 will be divided in 18 installments. Now first installment, here first payment will be equal to 1000 plus 10% amount, 10% interest of 18,000 amount, so 10 upon 100. So this is 1000 plus this will be 1800. This is interest. So interest with first payment. This is the interest with first payment. Then second payment again 1000 installment plus, when 1000 is paid from 18,000, now outstanding is 17,000. So 17,000 into 10 upon 100. So this is 1000 plus 1700. He is paying this 18,000 in 18 such installments, each installment of 1000 rupees plus interest of outstanding. So this is the interest of 18,000. This is the interest of left 17,000. Now again 1000 is left. So how much is left? 18 minus 2, that is 16,000. So in the third installment, third payment will be third installment of 1000 plus, after paying these two installments, 16,000 was outstanding. So interest on 16,000. So that is 1000 plus 16,000 rupees. So let me calculate total payment in such 18 installments. Similarly he pays 18 payments. So after paying 18 payments, he will complete 1000 1000 1000 18 times, that is 18,000 plus interest amount. So total payment, therefore let me calculate payment of interest only. So therefore payment of 18 interest, payment of interest amounts, it is equal to, say this is 1800 plus 1700 plus 1600 up to how many terms? 18 terms. So last will be, this is first term, this is second term, this is third term. So 18th installment will be 100 rupees At last this will be 100. So 1800, 1700, 1600, these are 18 terms. So last term will be only 100, or we can say 18 terms. 18 terms. So sum of these numbers, now here I am taking 100 common. So 18 plus 17 plus 16 up to 18 terms. So this will be 2 plus 1. So that is sum of 18 numbers, sum of first 18 natural numbers. So 18 by 2 into 18 plus 1. So this is 2 into 9, 18. So 900 into 19. So 171, 17,100 is total interest. Therefore, cost of scooter paid by Shamshad Ali is, in the beginning he has paid 20,000. Sorry, in the beginning he has paid 4,000. And then outstanding 18,000 in 18 installments, that is plus 18 times 1000, 1000, 1000 in 18 installments, plus total interest is 17,100. So this is 18,000, 4,000 plus 18,000 plus 17,100. So this is 22 plus 17,100. So 39,100 rupees. A person writes a letter to 4 of his friends. He asks each one of them to copy the letter and mail to 4 different persons with instruction that they move the chain similarly. That means, see, a person writes 4 letters to 4 friends and informing them to continue similar chain. Then those 4 friends again will send to their 4 friends. So this chain will be continued. Chain is not broken, and that is cost 50 paise to mail 1 letter. Find the amount spent on the postage when 8th set of letter is mailed. So here, first, second, third, etc. sets of letters are, see, the first set 4 letters are sent, in second set 4 square, so 4 into 4 16, then in third set 4 cube, so all 16 will send 4, that is 64. Like that, these are the sets of letters sent by this unbroken chain. Now we are asked to find cost up to 8 set. What is the cost when 8 set of letter is mailed? And here rate is given 50 paisa to mail. So let me find total number of mail. So here total number of mails up to 8th set, that is 4:1 plus 4 square plus 4 cube up to 4:8. This is GP. First term is 4. Common ratio is also 4. Number of terms 8. So as using formula A into r raised to n minus 1 upon r minus 1. A into R is to n minus 1 upon R minus 1. That is 4 by 3 into, now 4 is to 8 minus 1. So 4 is to 8, that is 4 multiplication 8 times. This is 4 is to 8. 4 into 4, 16. 16 into 4, 64. 64 into 4, that is 256. So 256 into 256. That is, here multiplying this, 6 into 2, 12, 1, 11, here 5, then 6, 33, 8, 2, 12, then 6, 3, here 3, here 15. So 6, 3, 5, 5, 6, 6, 5, 5, 3, 6. So this is 6, 5, 5, 3, 6 minus 1. So this is 4 into 6, 5, 5, 3, 5 divided by 3. Now is it divisible by 3? Let me check. 5 plus 6, 11, 11 plus 5, 16, 16 plus 3, 19, 19 plus 5, 24. It is divisible by 3. So 3 into 2, 6, 3 into 2, 6, 3 into 1, 3, 2 is left, 3 into 8, 24, 1 is left, 3 into 4, 12, 1 is left, 3 into 5. So this is 21845 into 4. So that is 4 into 5, 20, 0, put here 2, 4 4s are 16, plus 2, 18, put 8, 1, 32 plus 1, 33, put 3, 4 into 1, 4, 4 plus 3, 7, 4 into 2, 8. So 87,380 mails are sent. Now let me calculate cost of this mail. So total cost is mails is equal to 87380 into 50 paisa. 50 paisa, that is 50 by 100 rupees. So 0000. It is equal to 5 into 8, 40, put here 0, then 4, 5 into 3, 15 plus 4, 19, put here 9, then keep 1. 7 into 5, 35 plus 1, 36, put 6. Then 3, 8 into 5, 40, 40 plus 3, 43, 43,690 rupees.